Question about that little chart and how specific gravity works as a unitless multiplier. All right, now problem 10 after that is just a little bit more intricate. We're going to go ahead and work through this one together. But you're told that chloroform has a density of 12.37 pounds per gallon. And you want to convert that into a density of grams per milliliter, and then separately pounds per cubic foot. So two problems. Converting these units to these units, and then separately these units to these units. And there's a couple ways you could go about it. One way is dimensional analysis, and that's where you get the conversion from pounds to grams, you get the conversions from grams to liters, and liters to milliliters, and gallons to cubic feet, and boom, 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 you stack all those up, and that's fine. Specific gravity, though, is a little bit of a shortcut to that, and I'm going to show you how that works. This is the density of chloroform in pounds per gallon, correct? What's the density of water in pounds per gallon?
8.34.
8.34. And so if we make a ratio out of that, this is our very definition. Let me put this definition back up here. It was the density of X, X this case being chloroform, divided by the density of water in the same units. 12.37 divided by 8.34, 1.48. Chloroform is 1.48 times denser than water, period, regardless of what units you're talking about. By making this ratio, we know that chloroform is 1.48 times denser. Now look back at the chart at the top. What was water's density in grams per milliliter? 1. And what was water's density in pounds per cubic foot? And that's going to be 1.48 times denser, regardless of what unit frame of reference you're dealing with. That material is inherently 1.48 times denser than water. Shortcut. I'm a big fan of shortcuts. And this is one of them. This is a good, legitimate shortcut. Do you see how that works? Do you see what specific gravity is and why that's useful? The more you practice density, the better you're going to understand specific gravity, because it is a relative density that you use as a multiplier. Go ahead.
How will we use this in experiments?
In experiments? For example, because the density of water is very well categorized in lots of different units. And so this is one of those where if you've got an unknown material, you would take a portion of it, you would measure its density, and you would make the conversion. It's not something you would do on an unknown material, really, but it's something that you would make. It would be easy to make conversions for. See, if you wanted to know how much a pound of it, how much space a pound was going to fill, then it's a whole lot quicker to do this than it would be to go through all the dimensional analysis.
And could we use this here to identify different chemicals?
You could.
Like, so, like say we had a beaker full of chloroform we didn't know what it was. Could you use that to find a ratio?
Yes. I mean, it would probably be easier to just go ahead and do a direct density determination like you're going to do next week, where you draw off a certain volume and go weigh it. You wouldn't necessarily have to compare it to water to do that. But you could, you certainly could. That would, what you're saying would work, yes. Other questions? Yes?
Is it always going to be density over the density of water?
Yes, it's always relative to water.
Why is that?
Why? Water's a very well categorized reference point. I mean, you could go to handbooks and, you know, I've given you the density of water in 3 different units. You could, you know, the handbook of chemistry and physics gives you a whole page of them. Density of water in like 50 different units, whether it's, you know, kilograms per cubic meter and whatnot. And so it's very convenient to reference water because water is such a very well characterized reference point. So water is the reference point as a matter of convenience, if that's what you're asking. Okay. Other question? All right. We are ready to start temperature conversions, and so that means come Monday, we'll do temperature conversions. We'll do that one section on specific heat, and then we'll be moving on into Chapter 2. So what you should be doing between now and Monday is, number 1, go back through the study pack, repeat what we've done, and fill in the gaps of what we didn't do. And second, go on to the course website on D2L and pull out everything you can find about significant figures, dimensional analysis, density calculations, and work through all of that. All right, by Monday, get very, very good on what we've already talked about. All right? We are done.